Hello. Hello.
Yes, sir.
Hello, can Okay, okay. Okay, and today I'm going to start with okay, in the last class we have seen how to form, how to construct, okay, 4 by 2 decode, sorry, 4 by 2 encoder. And today class what we are going to do, okay, how do you construct 8 by 3, how do you construct 8 by 3 decoder. Okay, the 8 by 3 decoder otherwise called as a octal 2, otherwise called as an octal 2 binary encoder. Otherwise called as an octal 2 binary encoder. Okay. Okay, what do you understand from this? 8 is nothing but N2 and 3 is called as out. Okay, what is the meaning is we are going to provide input as a 8 bit and then it's going to produce output as 3 bit combination as a output. Okay, so now try to based on that what happen I'm going to try to form the truth table D3, D4, D5, D6, D7. Okay, so what are those output? A, B, C. Okay, suppose this is the input combination. This is a I want to generate three output. So in order to generate the three output, how many number of input combinations are available? 8. That is the meaning. Okay. Suppose D not equal to 0. So what happens, sir? So output is nothing but subscript of the particular bit. Okay. What is the subscript here? 0. So output is nothing but 0. What about next? Here 1. Okay, so what is the meaning is the output value is 1. Okay, here 1, next case here 1, the next case here 1, next case here 1, here 1. This is the last case. What do you understand from this at a time? So only one bit is enabled, the rest of the bits are disabled. That is the meaning. Okay, so what is the output of that respective bit in the sense? Suppose here 1, you go to the D value. So what is the subscript value is that there is a output value. Okay, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, this is a 1, next one is 2, the next one is 3, and next one is 4. Okay, next one is 5, the next one is 6. What is the 6? This is 6, 4, 2. Last one is 7. Okay, this is the respective output. Okay, okay, this is the truth table. Okay, what is the next task? So this is the specification. What is the specification in the sense? So 8 by 3 encoder. What is the meaning is you are going to take input as a 8 bit and then it's going to produce output as a 3 bits, namely called A, B, C. So this is called as a specification. So based on that, what happened? We draw the truth table. Okay, we draw the truth table. The next thing is nothing but we want to form the Boolean function. Okay, how do we form the Boolean function? Okay, here based on the output value. Okay, here how many number of outputs are available? Three outputs are available, namely called A, B, C. And then each one of the output, what happened? You should form Boolean expression. Okay. So first, what happened? I'm going to form the Boolean expression for A. How do you do that? You look at the output. What are the places output equal to 1? You take the respective input combination. Okay. This here output equal to 1. What I'm going to do? I'm going to take the respective input combination. 3, 4, 5, 6, 7. Okay. Okay.
So you take the respective input combination. Here what happened? Only one bit is 1. The rest of the cases are 0. Simply what you are going to do, normally how do you write it means d naught 0, d1 0. So we are going to write all the variables and then we are going to simplify that. Okay. So you can do that way also. So instead of that what happened? So I will tell the shortcut. For example, here the output value equal to 1. So that's why I'm going to take this that input combination. This bit alone 1. So simply what you are going to do, how do you form Boolean expression means you take the respective bit value, that is nothing but D4. Similarly, here what happened? Here 1 is there. So now what I'm going to do, I'm going to take the respective bit value. Here 1 is there, I'm going to take the respective bit value. Okay, you can do another way also. For example, you can write all the variable. Suppose 0 is there, you can write it as the complement format. 1 is there in the sense you should write as it is. And then after that, what happened? Make use of the postulate theorem. What happened? You can minimize it. Okay, you can do that. You can do that way also, but it's a very tedious process. Okay, you should write all the variable and then you want to minimize it. It is a tedious process. So okay, I'm telling that simplified version of simplification. Okay. Okay. Similarly, what happens? You take the next output. The next output is called as a B. Okay. You find out. So what are the places output equal to 1? Okay, these are the places output equal to 1. So I'm going to take the respective input position. Okay. So D2, D3, next D6, D7. So what about last output? The last output is C. Okay. And then you consider the output. What are the places output equal to 1? These are the places output equal to 1. You take the respective input combination. If you does in the sense, this is the answer. Okay, D1, D3, D5, and D7. Okay, now we got the Boolean expression. Okay. If after that what happened, you should. So what function we got it based on that what happened? You should draw that circuit diagram. Okay. So what is the functionality of A? A is a D4, D5, D6, and D7. Okay, this is the input for one OR gate. This is one OR gate. So this is OR gate. It's going to produce a result as A. So what about B? The B is D2, D3, D6, and D7. Okay, this is produce output as a B. So what about last case? D1, D3, D5, D7. Okay, so it produces output as C. Okay, this is a circuit diagram for 8 by 3 encoding. Okay, do you have any queries? Do you have any queries? Hello?
No, sir.
Hello? Okay. So,
No,
okay.
sir.
So next I'm going to list out. So what are the limitations are available in the decoder? Sorry, what are the limitations are available in the encoder? How to overcome those limitations? Okay. The next one is the limitation of okay, limitation of encoder. Okay. The first limitation is if two inputs are active simultaneously, active simultaneously, okay, the output of the encoder, the output of the encoder will be undefined, will be undefined, will be undefined combination. Okay, what is the meaning is, for example, so already we have seen the truth table of 8 by 3 encoder. Okay, What are the inputs are available? 8 inputs or combinations are available, T4 up to T7. For example, I want to generate uh, output output value equal to 0 on the scenes. At a time, what happened? D naught alone 0. The rest of the bits what happened? Sorry, D naught alone 1. The rest of the bits are 0. Similarly, suppose I want to generate output equal to 1. What happened? D1 bit alone 1. The rest of the bits are 0. So here what happens? Suppose here I'm going to consider one example. Here what happened? So D naught and D6, both of them what happened? Both of them what happened? Enable. At a time it's enable. Okay. That case is what happened? It's unable to predict that output combination. There is a drawback. Okay, overcome this drawback, what happened? Okay, what happened? They go for priority encoder. We overcome this problem, what happened? They go for the priority encoder. The priority encoder, what they are going to do? Suppose I'm going to take one input combination D0, D1, D2, D3, D4, D5, D6, and D7. Okay. Here, what happens? Suppose these are the two bits are at a time active. Okay, how to overcome this problem means, for example, I'm going to use the avoid this problem. Suppose at a time two bits are enabled, in the sense the output is undefined. In this case, is what happened? The output is undefined. Okay, how to overcome this problem means make use of the priority encoder. Okay, so what is the meaning of priority encoder? It means, okay, okay, suppose in this, consider this example. Okay, suppose the D naught big value equal to 1 and D6 big value equal to 1. Okay, sir, while predicting the output, which case I am going to consider? Okay, so the what the priority encoder is trying to say that which bit has highest priority you consider for output generation. Okay, so what is the meaning of priority encoder in the sense? For example, here D naught value equal to 1 and D6 value equal to 1. If it is there, we are unable to predict the output. The output is undefined. So resolve this problem, what happened? We go for the priority encoder. So priority encoder, what we trying to say that in the sense, if the such cases exist means, okay, how you are going to predict the output? Output means which subscript, which input value has highest priority. Okay, that is treated as a output value. So in this scenario, which one has highest priority? 1 or 6? Sorry, 0 or 6? 6 has highest priority than 0. That's why now what I'm going to do, I'm going to consider output as 6. Okay. Okay. All of you, it's okay for you? Hello. Okay, the main objective
Yes,
is
sir.
nothing but suppose you are going to take the two input combination. In the input combination, so more than one bit had the value equal to 1. Okay, that time, sir, which case I am going to consider as output? So in order to work with this problem, we go for priority encoder. So what the priority encoder is trying to say that in the sense, the highest value subscript, okay, the highest subscript value, highest subscript value, highest subscript value, consider as consider as higher priority. Okay, higher priority. So that is the final output. So in this our example, what happened? D6 has D6 has highest priority than D0. So while making the output, what happened? I'm going to consider D6 alone. I hope that all of you understood. So this is called as a okay. This is the first limitation. The second limitation is, this is the first limitation. The second limitation is For example, these are the input bits are available. This is a 8 by 3 encoder. So how many number of inputs are available? D1, D2, D3, D4, D5, D6, and D7. Okay. For example, assume that here all the values are zero, all the bit values are zero. So obviously, what happened? Already we have seen the circuit diagram. Okay, already we have seen that circuit diagram. Okay, you apply all the input into that circuit diagram. What happened? It's going to generate the output is nothing but zero. So output is zero. Okay. Suppose, sir, this is the first case. Second case, what happened? I want to generate the output is zero. So in these cases, what is the input combination? D naught is zero. D naught is one. The rest of the bit values are zero. Okay, the second case is nothing but I want to generate the output value equal to zero. So for that, what happened? I'm going to write it as input combination. Okay. So in these cases, what happened? D naught alone, D naught bit value alone one. The rest of the bit values are zero. Okay. So what I'm here, what I'm trying to say there. Okay. The two different the input combination, two different input combination try to generate try to generate same output. Okay, consider here what happened, it going to generate the output equal to zero. Here also what happened, the output going to generate the zero. Try to generate same output. That is people call as an ambiguity. The people there, that scenario people call as an ambiguity. Okay, that scenario we call it as ambiguity. Okay. Okay. How to avoid this problem means, okay, how to avoid this problem means we are adding extra bits in the circuit, extra bit in the circuit. Suppose, so what is it for example, that extra bit value people call as a V. Suppose the V value equal to 1. So for example, in order to generate the output, what happened? So first it considered an input combination as well as that extra bit V. If the extra bit V equal to 1 in the sense, what happened? Okay, it tried to generate the output. Suppose the extra bit value is 0 in the sense, okay, it does not generate the output. Okay, I will show it in the diagram. You can easily understood that. So do you have any queries? So why ambiguity is occur? Do you have any queries? Do you have any queries?
No, sir.
The next thing is, I'm going to designing priority encoder. So why I'm going to designing the so next thing is, I'm going to designing the priority encoder. So why I'm going to designing the priority encoder in the sense, I want to eliminate that problems that is called as ambiguity problem. Another one is suppose more than one bit have the more than one bit has the input value equal to zero in the sense the output is undefined. That's why we go for the priority encoder. Okay, that's why we go for the priority encoder. Okay, now what happened? I'm going to implement the priority. I'm going to implement the encoder using priority. I'm going to implement the encoder using priority encoder. Okay, so for that I'm going to consider 4 by 2 priority encoder. Okay, the priority encoder is similar to encoder, but how it's a differ from the normal encoder means the normal encoder it's containing input and output alone, whereas in the priority encoder it had extra one more bit value that's called as a validation bit. If, for example, this is a 4 by 2. What is the meaning is? So it's going to take input as a 4 bit. Okay, D naught, D1, D2, D3. So what about output? The output is A, B, and C. Sorry, output is A, B. So already you said the priority encoder it had extra one bit that is called as a validation bit. Okay. So otherwise called as a valid bit indicator. Otherwise it's called as a valid bit indicator. Suppose the V equal to 1, then only what happen? Then only what happen? It generate the output. Okay. So it generate the output. Whenever the generate the output. Okay. So based on the specification, this is called as a specification. This is called as a specification. So based on that, what I'm going to do, I'm going to draw the truth table. Truth table. Truth table. Okay, 4 input combinations are available. D3, and then it's going to generate the output as A, B, and then B. Okay. Suppose I'm a user. Here four input bits are available. Initially, what happened? All the bits values are 0. All the bits values are 0. Obviously, what happened? It's going to generate the output value equal to 0. Suppose, sorry, okay, I'm going to consider initially what happened. I'm a user. Initially, what happened? I'm going to consider all the bits value equal to 0. Okay, assume that the V value equal to 0 in the sense. Okay, so while collecting the output, I'm not consider this row. Okay, so whenever the output equal the V value equal to 1, then only what happen? I'm going to consider this value. Okay, so next, now my task is I want to generate output value equal to 0. That's why what happened? D0 is 1. Okay, what happened? It's going to generate the output 0. When means V value equal to 1. Okay, so similarly, I want to generate output equal to 1. I want to generate the output equal to 1. That's why D1 is 1. So what happened? It's going to generate output 1. When it's going to generate the output means V1 equal to 1. Okay. So here I am putting X. Why I am putting X in the sense already I said. Suppose the input combination more than one bit had more than one bit values are 0. That cases, how do you that cases how do you predict the output means which subscript value, which element subscript value is higher, that is treated as a highest priority. So that is the output. So that's why so what I did is, so X means don't care condition. X means, what is the meaning is don't care condition. So what is the meaning of don't care condition? The X value may be either 0 or 1, whatever it may be. So what is the meaning is X value is either 0 or 1, whatever it may be. I don't bother about them. Okay. Here the highest bit value is a 1. So while considering the generating the output, I'm going to consider this input bit value alone. That's why the output value equal to 1. Similarly, what happened? I want to generate 2. Okay, I want to generate the 2. Okay. Okay. So the lower bit value, I'm not considering it. That's why I'm putting X, don't care condition. Similarly, I want to generate the output value equal to 3. So that cases what happened? I'm not bothering about lower bit values. Okay. So when it's going to generate the output means V value equal to 1. Okay. This is a truth table for priority encoder. Okay, it's okay for you. Do you have any queries? Do you have any queries? Sir, why somebody may have the question, sir, why you are putting X instead of 0? Yes, sir, put again. So already ஒரு ப்ராப்ளம் பார்த்தோம். What is the problem is, இப்போ ரெண்டு பிட்டோட வேல்யூ சிமிலரா இருக்கு, 1 1 இருக்கு. So while generating the output, which input value I'm going to consider? இங்க பாரு, அதை எப்படி ஓவர் கம் பண்ணியிருக்கேன் அப்படின்னா, which bit has highest priority value. இப்போ பாரு 0 1 கம்பேர் பண்ணு. Which one is had highest priority? 1 is the highest priority. So while generating the output, I am going to consider D1 bit alone. That's why lower bit lower bit whatever it may be, either 0 or 1 or I don't bother about that. Okay. Similarly for 2 and 3. It is okay for you? Hello.
Yes, sir.
So based on that, what happened? So based on that, what happened? I'm going to write the Boolean function. Okay. Based on that, what happened? I'm going to write the output. So based on that, what happened? I'm going to write the output. So once again, I'm going to write down the truth table. So in order to generate the Boolean expression, A, B, X, sorry, A, B, B, 0, 0. All the bits are 0. The V value equal to 0 in the sense it does not generate any value. That thing we represented as a don't care condition. 1, 0, equal to generate 0 output. This is 1, 0, 0, x, x, 1, 0, x, x, sorry, x, 1. So 1, this is a 2, this is a 3, all the V bits values are 0. Okay, this is a truth table. So now what I'm going to do, I want to form a Boolean function. Okay, while forming the Boolean function, so what you're going to do? Okay, you take the output parameters. Here three outputs are there. So namely called A, B, C. Okay. So first, what happened? And I'm going to consider A. So for that, what happened? I'm going to generate the Boolean expression. So D0, D1, D2, D3. Okay. Okay. So what are the places output equal to 1? This is a don't care condition. 0, 0, 1, 1. 0, 0, 0, 0, 1, 0, 0, 0. Next one, x, 1, 0, 0. The next one is double x, 1, 0. The last case is triple x, 1. Okay. Okay. So now what happened here? Okay. So, okay. 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 If, what are the places output value here? Here, what happened here? This is output value. Okay, this is output value. Okay. 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 Uh, so now here, what are the places output equal to 1? Okay, here and here. Okay. So x, x, this is the input combination. Here, here the output value equal to 1. So for that, I am going to take the respective input combination. What is the respective input combination? XX 10. Okay. Here, two don't care conditions are available. Okay, if two don't care condition means how many number of input combinations are available? 0, 0, 0, 1, 1, 0, 1, 1. Okay, so what is the meaning is these are the places the output value equal to 1. So what is the meaning is these are the places okay the output value equal to 1. Similarly, what happened? You take the next one. What is the next one? X, 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 1. Okay, the output value equal to 1. Okay, here three input combinations are available, three variables are available. How many number of input combinations are available? 8. 0, 0, 8. Okay, to write all the combination. Similarly, 0, 0, 0, 1, 1, 0, 1, 1. Okay, 1, 1, 1, 1. Okay, these are the places the output value equal to 1. These are the places output value equal to 1. These are the places the output value equal to 1. Okay, based on that, so what happened? Okay, uh, okay, you should here if you consider the okay based on that what happened? You should follow Boolean function. Okay, if you consider the table, the input parameter is nothing but 4. Okay. So I want to generate the Boolean function. Okay. How do you do that? So for that, how I am going to generate means I can generate in two ways. One is nothing but I'm going to form sum of min terms, make use of the theorem and encapsulate what happen. I'm going to minimizing. That is one way of generating the Boolean function. Another way is we are going to form the k-map. Okay, based on that we are going to minimize. Okay, you can choose any one of them. So I go for k-map minimization. I go for the k-map minimization. Okay, here the input is 4 bits. So 4 bit. Suppose my variable is a 4-bit means what happened? You take 4-bit kernel map. If you consider the 4-bit kernel map, how many cells are available? 16 cells are available. Okay, so D naught, D1, D2, and D3. Okay, labeling that table index 00, 01, 11, 10. Okay, try to fill up the table. Okay, so 00, 10, 00, 10, 00, 10. Okay, 01, 10, 01, 01, 10, 01, 10. Okay, 10, 10. Okay, 10, 10. Okay. What about next? This is okay. Everything is fine. What about next case? The next case, you fill up that. Okay, 00. Okay, 1, 1, 1, 1, 1, 1. Okay, okay. Okay, 00, 01, 00, 01. Okay, if you fill up the table, okay, the table should be appear like that. The table should be appear like that. Okay, these are the elements are available. Next, what is the next step? You want to perform grouping. This is a 16 cell kernel. What is the highest type of grouping? So that is called as 16 grouping. Second one is a 8 grouping. Another one is a 4 grouping. So this one is called as octet grouping. This one is called as a quad grouping. Okay, the 16 is not possible. The next option is 8. 8 is a possible. Okay, how do you form the group? Okay, this is a one group. This is a one group. This is another group. Okay, this is another group. Okay, if you solve that equation, what happen? You may get the value d2 plus d3. Okay, okay, okay. I will solve it. How to generate the d2 and d3? First, I am going to consider this group. Here, all the variables are changing, so the value is 1. What about this one? The fixed value is called as a d2. So here, what happens? It's going to generate the d2. What about these cases? Here, the fixed value is d3. So it's going to generate the output is d2 plus d3. So do you have any queries? So do you have any queries? Hello.
No, sir.
இங்க என்ன பண்ணிருக்குன்னு தெரியுதா? So why I did like that? Anyone provide explanation? Anyone give the so provide explanation what I did? Hello. சார் இங்க என்ன சார் பண்ணிருக்கேன்? What I did? சார் இங்க பாருங்க. எனக்கு இந்த இடத்துல மட்டும் தான் அவுட்புட் ஈக்குவல் டு 1. அப்படின்னா இந்த இன்புட் காம்பினேஷன் தான் எடுப்பேன். ரெண்டு இன்புட் காம்பினேஷன் எடுப்பேன். But what happened in the sense that in the input combination what happened? The 2 bits values are don't care condition. The don't care condition எப்படி இருக்கலாம் அப்படின்னா value maybe 0 இருக்கும். I don't know what it is. So நான் அதனால என்ன பண்றேன் அப்படின்னா 2 don't care variables are available. If 2 variables are available in the sense, how many number of inputs are available? 0, 0, 0, 1, 1, 0, 1. இந்த மீதி எல்லாம் rest of the places as it is நான் போட்டுச்சு. அப்படின்னா என்ன மீனிங் அப்படின்னா these are the places output value equal to 1 ன்னு அர்த்தம். Okay, similarly for what happened, I'm going to consider the last. Now, what is the last case? Here the output value equal to 1. That's why I'm going to take the respective input value. If you consider the respective input value, what happens? Three variables are don't care condition. So already you know that if three variables are there in the sense, okay, don't care any meaning the value should be either 0 or 1. ஏன்னா எது எடுக்கணும்னு எனக்கு தெரியாது அப்படின்னா எல்லா காம்பினேஷன் தான் எழுதணும். So three variables are there in the sense. How many number of input combinations are available? 8. So that's 8 input combination. So what is the meaning is the respective places the output value equal to 1. Okay. I hope that all of you understood that. That's why I forward to next one. Okay. Next what happened? I'm going to generate the output for. I'm going to generate the Boolean expression for B. Boolean function or expression for B. Okay, how do you do that? Okay, what are the places output equal to 1? Okay, here x 1 0 0 1 here and here. What about next case? The next case is x x 1. Okay, so this is how. Okay, here only one variable is there. So how many number of output combinations are available? Only 2. Okay, what is the meaning is? So these are the places the output value equal to 1. Consider the next case. So next case what happened? Sir, here three don't care conditions are available. So if 3 means how many number of input combinations are available? 8. Okay, you should write all of them. Okay, you should write all of them 0 0 0 0 1 1 1. Okay, this is a and then this is a 1. Okay, so these are the places the output value equal to 1. There is a meaning. Okay, these are the places output value equal to 1. So this is a four variable function. Okay, I want to generate the Boolean function. So how do you do that in the sense? Make use of Gaussian map. This is a four variable function. That's why I'm going to take for four variable Gaussian map. So D0, D1, similarly D2 and D3. Okay, 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Okay, and then fill up the table. Okay, if you fill up the table, the equation should be appear like that. Okay, 1 sorry 1 1 1 1 1 1 1 1 1. Okay, now successfully fill up the table, and then you want to minimize it. How do you do that? Okay, you want to perform grouping. Often 16 grouping is not possible. The next grouping is called as a octant grouping. It is a possible. What about rest of the cases? So here what happened? I can able to form quad grouping. Okay, if you minimize that equation, you may get the value is d3 plus d1 d2 bar. Okay. Okay. Do you have any queries? Do you have any queries? Hello.
No, sir.
Sir, already you know that K-map minimization. That's why what happened? Directly I'm going to write the answer. Do you have any queries in the minimization?
No, sir.
Okay. Okay.
No, sir.
So this is the equation for B. Similarly, what happened? You want to generate the equation for B. Similarly, what happened? You want to generate the equation for B. Okay, how do you generate the equation for V? Okay, if you consider the V, this place alone 0. The rest of the cases, what happen? Output value equal to 1. So this is a 0. Sorry, 1 0 0 0. The output value equal to 1. Don't care condition 1 0 0. The output value equal to 1. Here 2 don't care condition. The output value equal to 1. Here 3 don't care condition. The output value equal to 1. B. Okay. Here, okay. Here only here the output value equal to 1. Only one variable is there. So already you know that. So once again I'm going to repeat that. So only one don't care condition is there. So one variable means how many input combinations are available? 0 1 1. I'm going to take So both of them. So what is the meaning? These are the places output value equal to 1. So what about next case? The next case is double don't care condition 0, 1, 0. The output value equal to 1. So two variable means how many number of input combinations are available? 4, 0, 0, 0, 1, 1, 0, 1, 1. Okay. These are the places output value equal to 1. So next you consider this one. So three don't care three variable don't care conditions are available. So obviously what happened? How many number of input combinations are available? 8. 0, 0, 0, 0, 1, 1, 1, 1. Similarly 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1. So what is the meaning is these are the places the output value equal to 1. Okay, how do you minimizing it? So in order to minimizing it, what happen? I'm going to consider 16-bit corner map, sorry, 4 variable corner map. It associated with the 16 cells. It associated with the 16 cells. So D0, D1, the next one is D2, D3. Okay, you fill up and then you should label your corner map 1, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0. Okay, so all the places what happen? Okay, without the first place, the rest of the places, the output value equal to 1. Okay, so now what happened? We want to perform grouping. I want to generate the expression for V. Okay, so for that, what happened? I'm going to perform minimization. So here, how many number of, so what is the maximum size of grouping here possible? 16 is not possible because here one place, what happened? The value equal to 0. So 16 grouping is not possible. Next grouping is called as a 8 grouping. Here 8 grouping is possible. This is second 8 grouping is possible. What about next case? Here 8 grouping is possible. Similarly, here 8 grouping is possible. Okay, 8 grouping is possible. Okay. Okay, try it out yourself. Already we have solved a lot of problem regarding K-map simplification. If we simplify that K-map, what happened? You make it the value D0 plus D1 plus D2 plus D3. Okay, this is a final value. Okay, so now we got all the Boolean expression. So final task is nothing but based on that what happened? You should draw the circuit diagram. Okay, do you have any queries? So in this, how to generate B? Hello.
No, sir.
Okay. So next what I'm going to do, I'm going to draw Boolean the logic diagram for priority encode. So what is the equation for A? A is D2 plus D3. What about B? The B is D3 plus D1 and D2 bar. What about B? B is D0 plus D1 plus D2 plus D3. Okay, you should write the logic diagram. Okay, D2 plus D3. Okay, it's connected with the one object. It's going to generate output as D3. So what about next one? D3. So D3. Okay. What about next case? So next one D3. Okay. Next one is D1. Okay. Here D2 followed by one inverter is there. We want to generate D2 bar. Okay. It's added with one AND gate. Okay. What happened? So this is an input for OR gate. It's going to generate output as B. Okay. What about next case? What about B? So B is D0 is secure. D0. Okay. What about next one? D1 is secure. No problem. D1 is secure. What about next? D2. D2 plus D3. So D2 then D3. Okay. So this is a circuit diagram for B. This is a circuit diagram for Okay. So now what happened? I'm going to take one test case whether the circuit is working properly or not. Okay, what happened? So now what happened? This is my input condition. Okay, D naught equal to 1, D1 is 0, and D2 equal to 1, and D3 equal to 0. Okay, so you may guess the output. So which subscript has highest priority? 2. So maybe the output value equal to 2. The output value equal to 2. I'm going to check that whether it's going to generate or not. Okay, so here what happened? The D naught here 1, here is 0, D3. D3 is a 0. So what about next one? This is a 0. D2 is 1. Okay, here what happened? Generate 0. Here 0. D1 is 0. So obviously what happened? This is a 0. Okay, this is a 0. This is 1. What about next V? So D naught is 1. What about D naught? D naught is 1. What about D1? The D1 is 0. What about D2? D2 is 1. What about D3? D3 is 0. Okay, this is OR gate. Okay, what is the meaning? What is the functionality of OR gate? If any one of the input is 1, obviously the output value equal to 1. Okay, the final output is AB. Okay, 1 0. So what is the meaning is 1 0 is a binary representation of 2. We successfully we attain the output equal to 2. Okay, do you have any queries? Do you have any queries?
No, sir.
Okay. No. Okay, thank you so much. We will see next week. Okay, thank you so much. If you had any queries, to be stay on online. Otherwise, you can wind up the session.
Sir, portion for cat eggs.
Hari, எப்போ ஸ்டார்ட் ஆகுது ஹரி?
Sir, இன்னும்
ஸோ அக்டோபர் 8ன்னு சொல்லியிருக்காங்க சார்.
2 days before we will decide that.